Hey everyone, this is Pritham, and in this video we will see the second check, that is the check for the member forces in a model in ETABS. Okay, so basically we are dealing with this G+3 story building. So as of now we have seen for the displacement or the deform shape how we do that. So basically, we see for that in the case and the combination and in the mode format. Okay, so we will generally do for this dead load plus live load, and it was the limit as of the 20 mm. Okay, just close it and undeform this shape. Just undeform them. After that, we will see for the check member forces. So how to do it? Here it is the option present of the display frame, pier, spandrel, and the link forces, and it can be directly do it for by clicking on the F8 on the your keypad. Okay. So how to do in this menu bar, there is a option present here as display. It is present in this four stress diagrams. Here it is the option of the frame forces. Just click on it or directly choose this option. Just I will close and directly choose this option, and you will be seen with this window, that is the member force diagram for this frames, pairs, pattern, links. Okay, then we will be dealing with this combination. As the you can choose here as the dead, live, as per your wish you can do it, but I will be doing it, means you can check for each and every combination. Here it is present that whatever the load combination we have added, it is present for that. Okay, in the case whichever type you want, you can do the this component, like whatever the force for axial force, means actually force what is coming for a particular case, dead load, live load, and the earthquake load. All this is been seen here particularly. So basically we will be dealing with this dead load plus live load combo. Okay, as of now. So dead load plus live load is taken as the combo for the load cases and the load combinations. In this the component, what are the present? The component are present in the formats like the axial force, shear force, and the movement and the torsion. We can check all of this. So basically we will be checking one by one. So first of all we will be checking for the movement about 3 and here I will just choose here as the scaling option, and here display option, choose both of them as the field diagram and the show values at the controlling station on the diagram, and here include frame. I will show you show you all the detail of it. Just click on apply, and you can see that the bending moment diagrams are being shown here. When you just uncheck this field diagram and click on this apply, then you can see that the feeling that was been present has been gone. Okay, but we generally apply this field. Just click on apply, and you can see that the color is being shown, how it works actually, how it is looking actually. This is the yellow part is showing in the as the sagging part, and the upper part is called as the hugging. Okay, as you should know all the detail of it, so I have shown you the two cases. Okay, but as you see here that it is very complicated to see whether what are they coming or not. So there is option, the dimension, the units are being present here. Okay, so it is very complicated to see the all the results. So just uncheck this show values at the controlling station on the diagram, and just click on apply, and you can see that the all the details have been gone. Like the same way you can do it for the 2D plan view also. Just choose your M3 and just click on apply. This M3 is the moment about 3. There are the two axes, one here and the second another here. Movement about 2 axis here, and movement about 3 axis here. Okay, just if you want to see more detail, just click here on the show values at the controlling station on the diagram. Just click on apply, and you can see that particularly the values of the dead load plus live load for the particularly maximum are being shown here. Okay, so if it is very complicated to see, so there is option, just close this, and you are currently seeing in the moment about 3 format, means the bending moment is working. To see the particularly for a particular beam what to do, then for a particularly scene for a beam, then here it is option present as when you just move on that particular beam, there is a option shown here as the plus icon is being shown. When you right click on that beam, you will be seen with this more detail. As you can see that the beam is been highlighted here. You can after right clicking, you can come directly to this diagram for the window with the diagram for the beam 72 B72. That's the beam number. that the component is of the beam and its number is B72 at a story roof with its dimension is basically 200 cross 300 mm. Okay, all the detail are being shown for that particular beam with for the shear force, moment and the deflection. What is the deflection, what is the shear force, and what is the bending moment coming for a particular beam. So you can see here the maximum bending moment and the shear force coming, that it is coming as of the maximum is coming in the hogging moment. Okay, here as the moment at the end of the at the starting is been shown, it is about minus of 6.3 kilometer meter, and here you can see the value of the show maximum. Okay, here same thing, we can choose the load combination as per whatever you can need. I will be checking for the dead load plus live load, and for that you can check it for the load cases, particularly for the dead, live. Okay, what are the coming, what are the movement are coming at particular distance, what are the movement comings. Okay, these are particularly load transferred from the slab to this beam. Okay, this movement are being shown particularly when the slab transfer the load to the beam. As you see here that for a shear force diagram, it is the straight line from one here into the another, it is a straight line, but you can see that the gaps are being seen here for because it has been seen because it will show us the load is transferred from the slab to the beams, so it will transfer it with the different points. Okay, so like that's why it is shown in this format of the force is being shown here and the movement are being carried like this way. Okay, for the live load they have been taken, for the dead they have been taken like here, but we deal with this load combination with the dead load plus live load, we can get all these values. Okay, so as you can see that the display location maximum values are being shown here. Basically for the shear force, the maximum value for the 0.2 is present at the 0.2 meter. One thing to note that the distance are being the dimension are being of the shear force and the bending moment are being shown from the particularly distance of 0.2 meter, that is the end point. As you, and once more thing, I will close this and I will zoom out here, and when I will extrude this view toggle, and you can see that this wire not this 0.2 meter has been cutting because of it will take from this end, not from the center. The bending moment is taken from this end, so this part is been not taken. Okay, like this way it works. As you see also here that when I extrude it, the values are being seen from this end, not this. Okay, so like this way you can see the values are being seen from this way. This is the 0.2 meter values. Okay, like this way you can see here in this 2D view also of the plan view. Here you can see that the values are being taken from here, not from the center. Like this way we can see the result of it in this format. When you right click on this model, when you just undeform, once again I will go to this member forces and just choose here as the moment about 33, and you can see all the detail are being shown here properly. Then when you right click on it, the details are being shown properly here. The shear force diagram results are being shown here. As you know that the shear force is being seen in this format. The bending moment is being shown in this format. Maximum bending moment is seen here in this place, but here the hogging moment is more, so the values at the hogging moment are more. As you know, as per our method, that is how to calculate the bending moment, WL square by 8. Like this way we can calculate the moment. And the third option here is the present of the deflection, and how to calculate the deflection. Don't choose here relative to the beam end. Here always choose here as the absolute deflection. We can see the result of it as the absolute deflection coming on that beam. Particularly it is coming at maximum deflection is coming at 2.5 meter at which is completely at 1.571 mm, which is okay. Okay, like this way if it is less than 20 mm, then it is okay. Just click on OK, and you can see that the bending moment diagrams are being shown properly. Okay, like this way we see for the bending moment diagrams. Then we see for the another format as the shear about 33. These are being shown in the format like this. As you know that for the shear it has been acting on this end points. This is the 3 direction and this is the 2 direction. We will see for the 2 direction also. This is the 2 direction and this was the 3 direction. all these details are being seen in the ETABS. Okay, as you see that for the shear, as we move downward, the shear values decreases, and as you move for the shear about movement values, they are, as you see here, 8 point. As you see here that it depends on the particularly the beam, the moment values, and for the shear the values will be, as we move downward, the values will decrease. Okay, now that was the moment. The same with the shear about 2 is being seen here. Moment about 2 we can see here that 2 and 3 are the direction. Okay, now as we have completed with the moment and the shear force, now we will be seeing for the next part, that is the axial. So I will just choose here as the 3D. Then in this 3D view, then there is an option here as the display frame. Just click on it. Member for the member forces. Here for the load combos, dead load plus live load, we will see for the axial force component in the form of axial force. Just click on this axial force, and we can see the axial force limits there. Here choose the scaling as the automatic, and the display option here choose as the field diagram, and the show values at the controlling station on the diagram, and include here as the frames. Just click on apply and just click on OK, and you can see that particularly these values are being shown here properly. Same way we can if the values are too complicated to see, then we can show or click here, uncheck with this show values at the controlling station on the diagram. Just click on apply, and you can see that the values are not being seen particularly. When you click on it, the values are being seen particularly. Okay, like this way the values are being shown or not. When if you want more detail of it, just go on that particularly column. These are the axial force are particularly for the columns only. Okay, the maximum axial force coming here is the minus of 325.9286 here at a particularly end. But to see it in the more detail, just right click on this column, and you can see it in the more detail form. That is the diagram for the column 1. You can choose any column and see it all details. Okay, like this way. The diagram for the column 1 at the story ground floor, that is the 300 cross 400 column, it is present. Okay, as you can see here, the beam is present, so that this part is not been taken here. This much part is not been taken because the beam is present here attached. Okay, so we will be dealing here with the same way. All the load combination and all these materials are being present here. For a load combination, equivalent loads are being seen here also. What are the equivalent loads coming at the downside and the upside? But we see for the load combination, dead load plus live load, and here you can see that the axial force and the torsion values are being seen here properly. Here we can see the maximum values with what are they coming. Basically for the axial force, the values maximum values are came at the bottom part. Okay, like here the values are been coming at the bottom part. As you see here, the upper part is minus of 268.81 above the ground level. Okay, at the foundation level the values is minus of 325.9286. okay, this values are being seen. You can scroll for a particular value and see the detail. Just click on 2, and you can see the value is coming as the minus of 319.93, means it is moving downward here, and it is shown the value for the 2 meter, and this value is about 319.93. just click on OK, and you can see also for the torsion values also here. Just click on done, and like this way you can see the all these values with this format. Just click on OK. Like this way we can see all these values. Okay, then after we can see for the in the next video we will see for the reactions. Like this way we will deal with the this axial forces. So how to see it in the plan view? It is not able to see in the plan view properly. Just then also I will show you apply. Just click on OK. Because in the plan view it deals with only the beams, no columns are being shown, so it will not show the values. So in the 3D view only it is shown, and in the elevation format it is also being shown properly. Just click on this apply elevation format here, and here choose the one grid here. Then after clicking on this one grid, you can see all the detail of it in the format like 1A, 1B, 1C, 1D, and all this. Just click on apply and just click on OK. You can see the all the details of this in the format as 1A, 1AB, and 1F till 1F. And you can see that as we move downward, the axial force is been larger. is large. When you right click on it, you can see the detail of it. Okay, just click on OK, and like this way we have seen how to check the member forces in ETABS. Okay, in the next video we will see for the reactions. Whatever the reaction are coming at the bottom part, we will see in the next video. So that's it for this video.